Today guys, been here. Previously we did a little exercise about a pattern-based family. So today we're going to do a new family, so quite similar to that one, but this one will be slightly different because we are going to make this panel to the size of the panel. So if you look at this panel, all these triangular shape panel, so 1, 2, 3, 4, 5, 6, we will be able to open it and close it, but the panel size will stay the same. Okay, so for example, you can open this up, but the size of this triangle shape will stay the same. Okay, so let's do it. So first, create a pattern-based family. Select the grid, change it to triangle flat. Okay, so now we're going to select this grid and we're going to adjust the grid. So for example, I'll change the horizontal to 1 meter, and we will need to be 1732.1. So the reason why we have this number is, so I'll just do a quick screenshot. So we need the length of the edge to be the same, and then to this is h. Okay, this is h, and this is v. So because this, in this triangle, this will be 60 degree, and if I connect this to here, which this is v, this is h, and we know that v equals square root 3 times h. Okay, so this comes from tangent 60 degrees equals 3 divided by h. So if you try to find the tangent 60 degree, that's square root of 3. So okay, so v equals square root 3 times h. So this is how we get this 1732.1, because this is 1 meter times square root of 3. Okay, so now let's continue. So first we're going to place some points, and before that I'm going to change the scale. So I want to make the line thinner so we can see the point. Okay, so first draw on face and place 2 points on these 2 reference lines, and then select this one and this one, create a spline and check this reference line, and then select this one and this one, spline and reference line, then place another point, draw on face and place it on the reference line, select this point, host point by intersection, so, and pick this reference line. So now this is the center point of this triangle. Okay, so now place a point, draw on work plane, set work plane, and pick the horizontal work plane of this point, and then place this point, and OK, and then select this point, drag this blue arrow so it goes up. So this will be the base, the point, so where when the panel is closed, so this will be the point, so where to place those panels. Okay, so I'll create, so select this point, create a parameter, I'll call it base offset, and type parameter, and OK, and OK. So now place another point, draw on world plane, set world plane, and pick the horizontal world plane of this point, and then place it on this point, and OK. So again, select this point, the new point, drag this up. So this will be the actual location of one of the points for the panel. Okay, so we will have 1, 2, 3, 4, 5, 6 panel, and each panel will be a triangular shape. Okay, so this will be one of the panel, one of the point of that panel. So select this point and create a new parameter. Let's call it offset and instance, and OK, and OK. So now we need to place another 2 points. So draw a face and place it on here and also on this reference line. So then select these two select these 2 points and create a spline through points and make it reference line. So again, this one, and reference line, and this one, spline, reference line. So now we have these 3 reference line. We can create a panel, and also this panel you can create a thickness parameter. So if you want to, okay. So let's change the thickness to maybe 20. Apply, and OK. So if you want to, you can also create a material parameter. And now I'm going to what we're going to do is, so this point will go up and down. Okay, so and then what we need to work out is, so this point, the location of this point. We know that when this point is sitting at this point, which is 0 offset, this point will stay on point 1. But when we move this point up, because this panel, it needs to be the length of the edge need to be stay the same. So which means if we move this point up, this point will go this way. Okay, so we just need to work out what the offset of this point need to be in relation to any other parameters. Okay, so let's do it. So first, I'm going to just screenshot this and I'll explain to you. So here, let's have a look at this one. So start. So this is a panel. It will start from these 2 points. Of course, another point here, but I'm not going to do it now. So we only look at this in this plane. Okay, so this vertical plane, and then I'll draw a line to here and also connect this. Okay, so this is one of the triangles. So this is 90 degree and this is BO, base offset. We already know this, right? And what is this one? What is this one? So we know that this one equals this one because this is 30 degree, this is 30 degree, these two angles are the same, so which means the length of this edge and this one will be the same. And also because this is 30 degrees and this is 90 degree, and this will be 2 times this one. So if this edge, so this one is 1 and then this one will be 2, so which means this one is 2 as well. So, and also because for the grid, this is H, right? And this one is V, which means this one is 2/3 of V. So now we know this one as well. We know this one, and then we can work out the edge of this panel. Okay, so because we in a triangular shape, if this is A, this is B, and this is C, we know that C square equals A square plus B square, right? So in this triangle, we can work out that this edge, so if I call it, what do we call it? Panel, let's call it P, okay? So if this P square equals BO, base offset square, plus this 2/3 of V bracket square. Okay, now let me change the color. And now we move this point up. Okay, so I'll draw another just next to it to here. And we know that the edge of this triangle, so this panel will stay the same. It's still P, same P, right? And this point will move from here to here. So I'll call this offset, let's call it X. Okay, so this point. And then we can work out that this part equals here. So 2/3 of V minus X, right? And what is this? This is BO plus OF offset. So we know this one as well. This is offset. This is base offset. So now we know this one. Once again, use this formula. And then we P, because same P and P, so equals. So in this new one is BO plus OF bracket square plus 2/3 of V minus X bracket square. So now we have this one. Okay, you might think that it's very complicated, but actually it's not. Okay, so let me explain to you. So I need a little bit more space. Yeah, that's better. So let's do it. So first, what I'm going to do is I want to keep, so because in this formula, so the final result, what we need is X equals what, okay? So from here, we know we can find that X only exists here. So I'm going to just keep this part, okay? Keep this part, and then I'll just work out what's the rest. So here, so from this one, I'm just going to do this way. So here, I'll keep this one, 2/3 of V minus X square. And I'll move this to this side. So it becomes BO square plus 4/9 of V square minus here. So, oh, sorry, this one. We just need to BO square, right? And minus 2 times BO times OF, and then minus OF square. Okay, and then BO, we can get rid of the BO, and so we know we have what's rest. I'll just do this to here. So equals, and 4/9 V square minus 2 BO OF times OF minus OF square. Okay, and then I'll just get rid of the square and I'll put a square root here. Okay, and then this becomes 2/3 of V minus X. I'll move this X to here, so which means equals X, and I'll move this to here, so it becomes 2/3 of V minus square root of everything in here. So I'll just do it again. So not for 9 v square minus 2 v o f minus o f square. So this will be it. So x equals this. I'll get rid of this, get rid of this. X equals this. Okay, this is our formula for here, this. Okay, so it's not hard, right? Okay, so I'll just hang on, I need to move it. Yeah, okay, so now let's go back to this family. So select this point. So we need to create a parameter. So change this measurement type to segment length. Okay, so now it's 177. I think that's about right. So if I move it, it becomes smaller. Yes, so this is the x, and then we just create a new parameter. I'll call it x. Okay, instance, and OK, and OK. So now we just need to go to family types. So under here x, we'll just need to type in this formula. Okay, so it's 2 divided by 3 times v. Okay, so we don't have this v. So let me just delete this. Before we create this formula, we need to create a v parameter. Okay, so it's not this v because we can't create a parameter for these. These will be controlled in the mass. Okay, and we will try to match the v to the v in the mass. Okay, so let's just create a v parameter v. Okay, so instance and OK and OK. So let's go to family types again. Under x, I'll type in hang. Let me check this v, what the v of this. I'll copy this one and then go to family type. I'll just type it for now, and later we will link this v to the actual v grid in the mass. Okay, so now x equals 2 divided by 3 times v minus sqrt square root of 4 divided by 9 times v square minus 2 times base offset times offset minus offset square bracket. Oops, the following is not valid. Okay, so space. Yep, so that's it. Okay, so now let's have a look at this. So I have a test. If I drag this point up and down and see what happens. Okay, so drag this up and down. See, can you tell that the edge, the length of this edge is not changing? So looks good. Okay, so I'll just move it back a little bit, and we will need to work out the offset for this point as well. Okay, so actually it's very similar, but the only difference is on this side when we do this. So this from this point to this point, that's 1/3 of v instead of these. So previously when we do this triangular shape, this from this point to this point, that's 2/3 of v, but in this, for this point, so that's 1/3. So we just need to go to family types. So let's create it from this. So this is x. I'm going to create a y parameter instance and OK, and I'll just copy this formula, and where there's 1, 2/3, I just need to change it to 1/3. So for example, I'll change this one to 1/3, and here, so this is 4/9 is the square of 2/3. So I'll just need to change it to 1/9, which is 1/3 square. Okay, so if I click, so apply, OK, and then select this point, change it to segment length, link this to Y, and OK. Now let's have another test. So I'm going to just click on this point and let's try. So if I drag this, so see, maybe like this. Okay, so I think that's it. So see this, the length of this edge is not changing, the length of this edge is not changing. Okay, and yeah, that's it. So now we can place the rest of the panels. So one here, so looks like we need another point here, so I just create a point, place a point, draw on the, place it on the middle point, and also I'll connect these two and make a reference line, and then place point, draw on face. So we need one point here, so also we need a point here, a point here, a point here, a point here. Okay, so now we can just connect these points. So spline, reference line, and also this one to this one, spline, reference line. Okay, so this is another panel, and then this one, spline, reference line, and this one to this one, spline, reference line, 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 this one to this one, spline, reference line. So I think that's all we need. And then 1, 2, 3, create form, solid, link to thickness. Okay. 1, 2, 3, create solid, link to thickness. Okay. 1, 2, tab, oh, here, create solid, link to thickness, and okay. 1, 2, 3, solid, thickness. 1, 2, 3, solid. Oh, sorry, wrong one. Control Z. Looks like I picked onto a wrong reference line. Create solid, thickness. Okay, so now we need to, so this is this is X, so this one is X as well, so just need to change to segment length X. Okay, so this one, where's my point? Here, segment length. So this one you need to change it to end. Okay, so and then connect it to Y. And this one, same. See, it's close to 1, which means you need to change the measurement from. So and then link it to this one's X. So and this one, come on, here. See, same, change to end, change it to segment length, change link to Y. So I think That's it. Let's have a test. So if I move this up, yeah, so good, looks good. Okay, so now that's the family. I think okay, so actually what I'm going to do is, so this way, if we move up to, too much, and you will break it. If you move up too much, see, it won't work. Okay, and so we just need to figure out what's the maximum offset we can have. So instead of use this offset control, we were going to use a percentage. So for example, from 0 to 100. But we need to figure out how to find a percentage. So what I'm going to do is I'll just temporarily hide some of the panels, and okay, so I'll just do another screenshot and to work out the maximum. Okay, so let me think. Okay, so I'll just do a screenshot of this. So now let's work out the maximum. So from this is the base point. I'll change the color. So this is the base point. When we move this point up at some point, so because the maximum offset, so I'll draw this line. So this is base offset. Okay. And if this is the offset, and the maximum offset we can have depending on the length of this edge. Okay, depending on this. And what is this one? So if I connect this one, this is this. They are the same. So what we need to do is we just need to use this one. Use this, the length of this minus BO, so we can get this offset. So this will be the maximum. Okay, but what is this? Because in this triangle shape, we already know this. This is 2/3 of V. Oh, hang on, sorry. This is a short. Sorry, my bad. This is the short part, so it's 1/3 of V. This is B, and then we know that this edge equals square root of BO square plus 1/3 of V square. And then if we minus, then minus BO become this offset, so it will be the maximum. Okay, so let's do it. So for this one, I'm going to create a maximum offset. So I'll call it max. Okay, max offset and instance, and okay. So max offset equals this formula. Oh, okay. So equals SQRT bracket base offset square plus plus 1/3. I'll just type in 1/9 times V square and bracket and minus base offset. Right. I'm missing something. Base offset SQRT plus right, not expected, so not this one, but hang on, something's not right. So base offset plus interesting, minus base offset sqrt, base offset plus, oh sorry, that should be a 2. Yep. Okay, so that's good. So now this is the maximum offset. So if I pass that offset, I will break this family. Okay, so now we have this one. We can create a new parameter. So I'll call it a percentage. Okay, and I'll use number and instance and okay. So I'm going to use this to control the offset. So offset, for example, I'll just type in 50. Okay, and then under offset, I'm going to use percentage times that. So I'm going to use max offset times percentage divided by 100. Okay, so now this will be the parameter we control this family. So if I click OK, let's have a look. So HR, and let's try this percentage. So 0. Okay, so that's fine. That's something's maybe point or yep. So see, it's close. And if we type 100, oh, that's fine. Yep, so it's open. Okay, so 60. And also just be aware that the percentage is not the opening percentage. Okay, so it's not the percentage of the opening, it's the percentage of the offset of this point. Okay, so I think it would be good to use the percentage of opening to control this family, but today I think we need some more few formula for this. I haven't done this before. I might have a look and see if we can use the percentage of opening to control this family, but for now the percentage is the offset of this point. Okay, so from 0 to 100, and then the result of the opening is so at 50 it's only very small opening. Okay, and you need to add roughly maybe 80 or 85% of the point, and then you will have maybe 50% of opening. So just be aware of that. Okay, so now let's I think that's all good. Let's have a look. I'll create a mesh, a very simple mesh, and have a test of this family. I'll just create a arc, something like this, and I'll create a form and drag this up a little bit. So I'll just use this divided surface and then change it to a triangle flat. And the first thing we need is we need to adjust the grid. Okay, so I'll change this to change this to fixed distance. Okay, so now I'm going to use roughly 3 meter, and so this will be the short one. So actually I'm going to use this as 1 meter, and then we know that this need to be square root 3 times 1 meter. So and I'm not going to do it. I'm going to do the formula here. So instead I'm going to create a new parameter in this mass. So this is V. I'll create a V and instance OK and OK. So and then here I'll create a view, and for you I'm going to go to family types. U equals sqrt square root 3 times v. Apply. Okay, so now we can just use this v to control the overall pattern. So for example, I'll change it to 2 meter, so the u change as well. So I'll change it to 1. Okay, so now let's load this family into the mass, and then select this and change this to this family. So now you will see this is it, but it's not finished yet. We need to select this panel. We need to link this V to the V in this mass. Okay, so select all, and I'll link this V to the V here. Oh, is that right? Oh, let's try. I'm not sure if it should be V or U. Okay, so let's have a test. So 85, if I change this to 0, looks like it's correct. Okay, that's great. So so let me select all. If I change the all percentage to 0, it will close this. And if I change it to maybe 90%, okay. And also if you look at this corner very closely, you will see it move the panel instead of change the size. Okay, so I'll change this one. So 0, it will move, the panel will move to this point, and at 50, it move away from this point. See? Hang on, it's not right at 100. Let me try this again. So maybe 99. Still not quite right. 0. That's correct. 80. 90. Okay. Looks like, hang on, I think I know what's happening here. I select all. I'll link this V. Instead of V, I'll link this to U. Okay, so now let's try again. So select all. Change this to 0, closed, great. Change this to 100, also not 1000, wrong one, sorry, Control Z. Wow. Anyway, that's not correct. Let's change this to 100. Yeah, that's better. So this is what we need. So at 100, it's almost vertical. Right, and then change it to 80. Great. Change it to 0. So let's do it once again. So if I select only one of the panel, if I change it to 80, 90, 99. Okay, so that's it. And also if you want to, you can change this to overhand. So you will have maybe, hang on, let me select all this panel and link this again. So link this to U, and then we can change the percentage to 0, 50, 70. Okay, so that's it. I'll upload this family for you, and you can have a look. Please let me know if you have any questions. I'll see you next time. Thank you. Bye.